Okay, now we know how to find objects inside this multi-index container. One thing we want to actually do, or also be able to do, is modify objects inside the multi-index container. Again, it's very similar to a database in that regard. So the container offers up these kind of different APIs in order to do this. The first one we'll look at is here. So we've already found the object, right, from a previous video. We found Bob. And what we're doing here is we're dereferencing this Bob that we found. Again, it's an iterator. So now we have the actual employee. I named the employee not Bob, right, because it's not Bob. We're going to change that employee's name. So now not Bob's name is actually not Bob. And what you can do is you can call this replace function on the name index. So here we're replacing Bob, the original object, with not Bob. And if you see, let's comment these lines out. If we compile this and print it out or run it, you'll be able to see that Bob's name is now not Bob. And in fact, that is the case. So this is a replace object, right? One of the problems is we have to copy Bob into not Bob in order to make a replace on Bob himself. So because of this space complexity trade-off, they offer you an ability to modify Bob as well. And the way you do that is up here. I've created this change name struct. I've given it a constructor and then an operator for employee. So what it will do is it will take, if you define this operator with an employee as a parameter, what it will do is it will take that employee object and then perform the operators on it. In this case, we created the change name by passing it a new name string, and we're storing it down here private. And what it will do is it'll take this employee, set the name equal to new name, right? That's what modify does in this case. So if we compile this now, we'll see that we changed the name back to Bob, quote unquote back to Bob, and we'll see the name actually be back to Bob. And in fact it is. One thing I wanted to point out, and you'll see here in this comment, I have object to modify, how to modify, and then roll back in the event of an exception. So I've passed three parameters. There's the object that we want to modify here, in this case is Bob, and then we used that struct above where we had overloaded the operator and passed in the string back to Bob. But the problem is what happens. So in the case of a replace, you can roll back immediately, right? If, let's say, this not Bob object does something weird and an exception gets thrown, well, you still have Bob himself as an object and you can roll back to that. But in the case of a modify, you're changing that object directly. And so you need to know what to do if something does go wrong. In this case, I'm changing the name to Bob itself. In this case, we didn't have an exception because everything went smoothly. Everything was fine. But if something were to happen, like, I don't know, maybe... Let's try this. I haven't actually tried this before, so let's see what happens. I'm assuming if we throw this exception... Oh, this isn't going to compile. Never mind. But if something were to happen in the struct, when you're editing the string or something like that, we would use this third parameter in order to change the name back to Bob in this case. Kind of picked a bad name or a bad string to put in there, back to Bob. When I say back to Bob, you don't know which one I'm talking about. I'm talking about Bob itself, the string. Finally, one thing you can do. So here it's kind of heavyweight, right? Because in this operator overloading right here, we're passing in an entire employee in order to just alter the name. What you can do here is, rather than passing in a full employee and editing it, you can just change the key, the specific key that you're trying to do, and that's what this API call here is modify _ key. This allows you to change the actual name of Bob rather than passing in the entire string. You can just change the key, in this case the name, rather than editing the employee directly. If we do that, we'll see that finally Bob's name getting printed out here is now key rather than back to Bob. And that's the final state of our object at that point. And in fact it is. Okay, so that's basically kind of everything you need to know about multi-indexes, how they function, all those things. There are two more sections I want to do with multi-indexes because I think they're kind of important. Well, actually, rather than that, let me just briefly talk about one of the more interesting aspects about this. So here's all the database operations. They go through those in detail. But one thing I think that's very, very interesting about these is this projection of iterators. So again, we have two different ways of looking at the data structure. You can actually pass these iterators back and forth between the two views. So you can maybe do a find operation in logarithmic time, but then maybe you want to iterate sequentially from there, right? So you could go find the object in logarithmic time, then pass it what they call a projection, right? You project that iterator back into the, let's say we wanted a list view of the data structure. You'd project that back into the list view, and then you can iterate back sequentially again. The one example they show here is the count, the word count. If you remember from the previous video, here they're getting the sorted index where the words are in sorted order so that they can look up the word sister in logarithmic time. But then they're projecting that back into the sequential, and then this allows them to append the word older to every occurrence of the word sister in the string, which is very interesting because you're doing this logarithmic lookup, then appending, and then doing another logarithmic lookup, and then appending. So although, like, if you were going to try to do this again in a list, it would take you linear time to do this. So that's one super interesting about aspect of multi-indexes, I think. So since we got that out of the way, we'll skip doing that video. But there is one more video, in fact, that I really want to hit, and that's at the very end of the documentation. They walk you through how to kind of write the original STL data structures in a multi-index form, which I think is very important because often the STL data structures don't function as you'd expect in smart contracts. At least currently, while I've been writing them, I've noticed that. But if you can mimic those STL data structures and using a multi-index, it seems much more supported in EOS smart contract development. So we'll look at that in the next video. We'll go through each of those, and then that should be it for at least Boost library multi-indexes. We'll talk about the EOS specific ones in a later video. See you then.